Alright, this is lesson 27 for 7th grade, and today's topic is multiples and least common multiple, or the LCM. We've seen an abbreviation like this before. That was the GCF. That was the greatest common factor. Today we're talking about least common multiple, and we're going to get into the difference between multiple and factor. But the big things we're going to talk about today. This is probably showing up fairly light on your screen. I apologize for that. We will learn what a multiple is. If we haven't learned what it is already, we're going to review what that is. And we're going to use our knowledge of multiples and prime factorization to find the least common multiple, or the LCM, between numbers. We'll be able to find the LCM, or least common multiple, between 2 numbers, 3 numbers, 4 numbers, however many numbers they give us. We'll be able to figure out the least common multiple. But the first thing that we need to know is, what is a multiple? Alright, well, it says here, the multiples of a number are produced by multiplying the number by 1, by 2, by 3, by 4, and so on. So, if we look at the number 4, it says the multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. Keeps going on, just like that. You'll notice that between each term, we're just adding 4. 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16, 16 plus 4 is 20. Keeps going on like that. The way the definition sets this up is that our first term here is 4 times 1. 4 times 1 gives us 4. 4 times 2, for our second term, gives us 8. 4 times 3 gives us 12. So basically we can see we're multiplying whatever number we're working with by our counting numbers. 1, 2, 3, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, and keeps going on like that. So those would be the multiples of 4. And just another set of examples here. Multiples of 6 then would be 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. And as you see, we just keep adding 6 in between each term. 6 plus 6 is 12, 12 plus 6 is 18, 18 plus 6 is 24. So those are examples of multiples of 4 and 6. Let's see, my eraser here. So what's the big difference here between a multiple and a factor? Difference between multiple and factor. Alright, well, let's take the numbers 4 and 6. Now we can see here that the multiples of 4 are all of these and keep going on. Now the factors of 4 are different. Factors, remember, are the things that can divide 4 evenly. So here are the factors of 4. 1, 2, and 4. Those 3 numbers are the only 3 numbers that will divide 4 evenly, so that we would come up with a whole number answer. 4 divided by 1 is 4. 4 divided by 2 is 2. 4 divided by 4 is 1. So those are all the factors of 4. And if we multiply 1 times 4, we get 4, and 2 times 2 gets us to 4. So basically all the factor pairs are things we multiply together to get 4. So those are the factors of 4. Here are the multiples of 4. A lot more multiples than there are factors. If we look at 6, what are all the things that divide 6 evenly? So factors of 6. And we'll make sure we separate these here. Factors of 6. 1 and 6, 1 times 6, 2 and 3. So 1 and 6 multiplied together give us 6, 2 times 3 gives us 6. Those are all the numbers that will divide 6 evenly. Also the numbers we multiply together to get 6. Like I said, 1 and 6 are paired together. If we multiply those, we get 6. 2 times 3 will give us 6 as well. So these are the factors of 6, multiples of 6, factors of 4, multiples of 4. So that's the main difference there. As we can see with these dots here, there will be an infinite number of multiples for any number. because you can always keep multiplying by the next number that you count with. Alright, so we just looked at the multiples of 4 and the multiples of 6. And we may have noticed that they had a certain amount, or they had, at least the ones that they showed us, they had some multiples that were in common. So they circled the ones that are in common here. 4, 8, 12, 6 to 12. So 12 they shared, 24 they shared, 36 they shared. We would call those common multiples. Alright? Now remember what we were talking about before. We were talking about the least common multiple. Now the least common multiple is the smallest, and we'd be interested in that in the future. The least common multiple of 4 and 6 is 12. Alright? And we saw that right here. They circled this was the smallest one that they had in common. It says 12 is the smallest number that is a multiple of both 4 and 6. So we call that the LCM. Alright? Remember we used the GCF in order to fully reduce fractions. We use the LCM, the least common multiple, to get common denominators when we add fractions together. So that's where we're going to use this later. We're going to use the LCM more often than not when we're trying to get common denominators. That's the big idea behind this. We're not going to use that today for fractions, and some of us have already been using it, but that's the big idea behind this LCM. And once we get into further education, when we're in high school and college, LCM and GCF come into play in a pretty big way as well. So, things to look forward to there. Alright, so let's look for the least common multiple of 3, 4, and 6. So, let's do this the list way. We'll say, okay, 3 has these multiples. You start with 3, 6, 9, 12, 15, 18. Hopefully that'll be enough. 4, 8, 12, 16, 20, 24, 28. Looks like we're going to have to keep going. Maybe. Let's check it out here. And 6. Well, let's make our top list a little longer here. Go by 3s. 21, 24, 27. Hopefully we have enough now. 6, we're going to go up by 6s. So 6, 12, 18, 24, 30. I think we already have a match here. So we're going to look for the ones that they have in common. And they have to all have this in common. And we're looking for the smallest one that they all share. So, least common multiple. 3s, no 4s, no 6s, 8s, 12s. Looks like we have 12 on each of these. Alright, looks like they all share 12, and that looks like it's the smallest one that they share. Alright, I guess I didn't need to make my list that long anyway, okay? But, it's good just to check. They also share 24, but 12 is obviously a smaller number. So that's their least common multiple there. I'm also going to check my video time here. Okay, we're doing alright. Now obviously if you have a lot of numbers, it's going to be kind of a pain to make this list. So, we don't want to write lists out every time we have to find the least common multiple of something or some numbers. So, it says here sometimes the numbers won't be so easy to work with, so we'll need another method to find the LCM. This method will actually help us find the GCF as well. Okay? So, here's something where the prime factorization can help us out. Alright, if we use the numbers 54 and 60, we can see how prime factorization can easily show us what the GCF and LCM will be. First, we need to find the prime factorization of both. Remember, prime factorization, and I have them written out already, we break them down into their prime factors. So, This is 9 times 6, 3 times 3, 2 times 3, and there are prime factors. So 2 to the first power, because we only have 1, and 3 threes. So 3 to the third, 60 real quick. I'll go 6 and 10, 2 and 3, and 2 and 5. Alright. Those are all prime. So 2 to the second, since we have 2 2s, 1 3, and 1 5. So we have everything to those powers right there that we need them to be. Alright, so here's how we're going to use this. If we're looking for the GCF, okay, we'll look at the common numbers and use the lowest powers, okay? So we'll look at, okay, what do they have in common here? They have a 2 in common and 3 in common. Okay, so we're going to be multiplying 2 times 3, but we want to use the lowest powers, okay? So the ones that they share, but we're going to use the one with the lower power. So they share a 2. Which one has the lower power? 2 to the first. So we're going to use that. They share 3s, 3 to the third, and 3 to the first. This one's smaller. We're going to use that. So 2 times 2 to the 1 times 3 to the 1 gives us 6. Okay? So that would be the greatest common factor there. That's the greatest number that they both share that will divide them evenly. Okay? Now for LCM, it's a little backwards. So for here we use greatest common factor and we use the lowest power. Now, LCM, we don't even look for what they have in common. We're going to use every number that we see at the highest power. Okay? So every number that we see here would be 2, 3, and a 5. So, and then we're going to use the highest powers of those. Highest power of every number. So what you can do for this is just say, okay, 2 times 3 times 5. And which one has the higher power? So 2 to the first or 2 to the second? Well, second's higher. 3 to the third or 3 to the first. 3 is higher than 1. This one doesn't have a 5, but this one does. So automatically you're taking this 5 right here, 5 to the first. So, if we multiply all these together, 2 to the second times 3 to the third times 5. If we do that, we'll get an LCM of 540. So, this is where this process, it seems a little weird, can help us out and save us a lot of time. Because we'd be making 2 lists that go out to 540 to find the least common multiple. So, they are a little backwards. When you're looking for GCF, look at your common numbers, and you're going for the lowest power. LCM, you take every number that you see, and then you're going to multiply the ones that have the higher powers. So it's a little backwards in terms of least and greatest. But those are the rules we follow that help us save time. Otherwise, we're making really long lists, and that's just not that fun. And it can get frustrating. So let's try that with a couple more here. And I want to check my time again real quick, I'm sorry. We are running low on time. So what I'm going to do is I'm going to stop right here, and then we're going to go through these. I'll make this part 2 of the lesson, alright? So come back and make sure you watch part 2. We'll go through these 2 with our new rule.